This lesson demonstrates a technique for changing the size of an image. Two images are loaded and then reduced in size and displayed in the same window. This is the Display Scale Canvas class that loads two of the images we've used in previous lessons and reduces both of them to the same size for display. The window is set to a rectangle 256 pixels wide, 128 pixels tall. This program will resize two images to fit side by side inside this rectangle. An image loader object is used to load the blue marble image from a file. The getScaledImage method of the image object is called to produce a new image. No matter what its original size, this method call will produce a version of it that's 128 by 128. Scaling requires that pixels be added, removed, or in some cases both. There are different ways of doing this, and you can specify the way you would like to have it done. This selection specifies that the new pixels be set to an average of the pixels around it. You can also specify Scale Smooth, which tends to produce a smoother image. Or you can specify Scale Replicate, which means that the new pixels will be an exact copy of one of the pixels adjacent to it. If you need speed, you can specify Scale Fast, and the fastest algorithm will be used. Or you can specify Scale Default, and the default algorithm, whichever one that happens to be, will be used. The default will vary from one platform to the next. Now this is a call to the same wait-for-image method that we used in the previous examples to wait for images to load from disk and from the internet. In this case, the method will wait for the image to be converted to its new size. This method will wait for a new image to be completely loaded no matter what its source. In this case, the source is another image in memory, with its pixel values being passed through a process to create a new image. With images as small as these, the transformation is very quick, but with a large image, it could take quite a bit of time. This same sequence of method calls is made to load the red marble image and use it to produce a scaled-down version. Once the constructor has completed execution, these two image objects should be ready to be viewed. They should each be squares of 128 pixels on a side. The two reduced images are drawn side by side in the window. The little red image is drawn on the left, and the little blue is drawn 128 pixels to its right, which should put the two images side by side and just fill the window. The class did not compile because, as you can see from these two error messages, the wait-for-image method is private and cannot be accessed from here. The logical thing to do is to make it accessible. Now it's a public method. We need to compile the class, so the class file will have this new information. Now we should be able to compile the display scale class without any errors. And that should make it possible to display the two images at once. Here are the red and the blue marbles side by side. Any image can be scaled to any size, but be careful when you are expanding them because you can wind up with indistinct pictures and jagged edges. When you shrink them like this, you almost always wind up with a picture of a quality equal to the original, but expanding the shrunken ones again can cause some deterioration because some data is inevitably lost when you do shrink it.